All right, we're going to look at the laws of exponents, the product rule. The product rule means that when you're taking a base raised to its own power, and then you raise that entire base to that power to another power, then we give this outside power to the inside power by multiplying the exponents. So we would keep the base and multiply the exponents. All right, so what this would happen is we would keep our base. This is b to the m power to the n power. So you can see how this works. You're going to have a parentheses, and you're going to have a power, parentheses, and another power. And that's how they're always going to be linked. So this would be keep the base and multiply m times n. And that's what that would look like. All right, so let's look at some examples. We'll start with numerical examples that you should know. 4 raised to the power of 2. So it's a quantity of 4 raised to the power of 2. This is the same as 4 times 4. This is its meaning, and we've talked about meaning in class. It's 4 times 4. So this means really 4 squared, which is then 16. For numerical bases to a power, you want to multiply them out and get an actual number. This is a quantity of x raised to a second power. You know its meaning is x times x. So all we have to do is, this is power of 1. We're going to give that power in here and say, okay, this is x to the 1 times 2 power, which is x squared. All right, so let's see it in a more complex looking problem where we have a quantity of 4r cubed raised to the second power. Okay, so we've got two bases here. The first base is 4, numerical, and the second base is r. So what we're going to do is take a look at the 4, and the power on 4 is 1 because we don't see a power on it, so it's got to be a 1. So let's write it so we see it. So this is going to give us 4 to the 1 times 2 power. So we're going to give that power in. It is not the distributive property, but an easy way to remember it is that we're going to give that power over to multiply by the power on that base. And we're going to multiply this by the base of r, so we're going to keep that base. And we're going to give this power of 2 over to 3, and this is 3 times 2. So when we rewrite our final answer, we get 4 to the 1 times 2 is 2, so 4 squared. R, and we don't drop the multiplication symbol, it's not necessary because it's understood. 3 times 2 is 6, so r to the 6th. Now, because 4 is a numerical base raised to the power of 2, we are intelligent enough to say, okay, 4 squared is 16. So we will simplify that. So that's 16 r to the 6th, and that is our final answer. All right, let's look at some more examples. We have the quantity of a to the 8th to the power of 3. Okay, so our base is a. A is being raised to the power of 3. So we're going to give that power of 3 to the power of 8, and we'll keep our base and multiply our exponents. So it becomes a to the 24th, because 8 times 3 is 24, and we are done. Okay, we have a quantity of 4t raised to the power of 2. We have two bases in here, a 4 and a t. So we're going to keep our bases, and we're going to put our powers on them that we don't see, so they've got to be 1s. So we're going to keep our base of 4, and we're going to give that power of 2 into that base exponent of 1. So 1 times 2. We're going to keep our base of t. We're going to give this 2 into its exponent of 1, so 1 times 2. So we keep our base, and we would multiply our exponents when we have a power raised to another power. All right, so this becomes 4 squared t squared. 4 squared is 16, so this becomes 16t squared. I'm going to throw another example on here, and I'm going to put in here negative 3. We'll make it g to the 3rd. We're going to raise that to the second power. Okay, now be careful with negative numbers or negative bases. Okay, that base is a -3. So what we have to do is we have to keep that base in its entirety of -3. Now it has a power of 1 because we can't see it. G has a power of 3. So we're going to keep our -3 intact. We will keep it in parentheses. And we will take the power of 1 times 2. So that's the power of 1 and 2. We're going to keep our G. And we're going to give that power of 2 over to 3 also. We gave it here. We have to give it to 3. So this will be 3 times 2. Now, this becomes -3 to the power of 2. This becomes G to the power of 6. -3 times -3 is the meaning of this. Again, we learned that in class way early on, carried it through the whole year. So this is going to give us a +9. So your negative is going to go away depending on what power is out here. Okay, and this is G to the 6th. So your final answer is going to be 9G to the 6th for this. All right. Quantity of 5, x, y, z. Every one of these inside here, every one of these bases, 5, x, y, and z, they're all different bases, have their own power. Since we cannot see them, they are 1. So it would be wise to put a 1. Now the whole quantity here is raised to a power of 0. And our zero power rule that we learned in a previous lesson is that any expression, variable, or number raised to a power of 0 is 1. Everything in here is being raised to that power of 0. So the answer to this is simply 1. All right, next problem. 5a squared b cubed, all raised to the first power. 5 has its own power of 1. We can't see it, so it's there. Write it. And it's being raised to another power of 1 out here. Everything in here is being raised to that power of 1. So we're going to keep our base of 5 and its power. We're going to give this power in, and when we give power to power, we multiply powers. We're going to keep our base of a. We're going to give this power outside to the power inside. A power raised to that power is going to be 2 times 1, because our rule says keep our base, multiply our exponents. And power to power here, we're going to give that power of 1 to the power of 3. We're going to keep our base b, and it's 3 times 1. So when we work this, it's 5 to the first power, a to the second power, and b to the third power. So this is just 5a squared b cubed. So any expression raised to a 1 power is not going to change the original expression. So there's no tricks here. Okay, I'm going to put a negative on this 5 here. Okay, so let's look at this one. We have 3af, all raised to the third power. Each base here, 3a and f, individual bases, have their own power. Since we cannot see them, they are 1. All right, so we're going to take those bases apart in 3. We give the power of 3, so it's a power of 1 to the power of 3, so 1 times 3. Keep the base, multiply your powers. Keep your base of a. Give that power of 3 into the power of 1. Since we're doing power to power, keep our base, and we multiply our exponents. Keep our base for f, give this power of 3 into this 1, multiply our exponents. So this is 3 cubed, a cubed, f cubed. 3 cubed is a number, so we can multiply it. It's 3 times 3 times 3, which is 27. So we're going to write this as 27 a cubed f cubed. And that's our final answer. Right, next one. We have a quantity of x squared y z to the 4th raised to a -5 power. X is a base, y is a base, z is a base. X has a power of 2, y has no power showing, so it's a 1. So we write it so we can see it. And z has a power of 4. So we're going to give our power of -5 into our power of z. So it's x squared raised to the power of -5. So we're going to get x, keep our base, multiply our exponents. So 2 times -5. Keep our base of y, give this power of -5 into this power of 1, 1 times -5. Keep our base of z, multiply our powers, 4 times -5. So when we rewrite, we get x to the -10th, y to the -5th, and z to the -20th. In another lesson, we are going to learn what we do to simplify an expression that has negative exponents. However, for the work that you're going to be doing, the negative exponents are okay at this time. All right, and we have one more left just to solidify this. 2 has a power of 1. H is a different base. J is a different base. I'm going to do this without all the steps now. Let's see how it goes. 2 is our base. We keep it. 1 times 4 is 4. H is our second base. Keep it. 3 times 4 is 12. J is our third base. Keep it. 2 times 4 is 8. And there's our final answer. Now, because 2 to the 4th is a number we can calculate, okay, 2 to the 4th means 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So it's 16, h to the 12th, j to the 8th. And that's our final answer. I'm going to add one more problem here as I'm thinking about it. What if we have -2? We'll just keep it simple. X to the 3rd power. Okay, our first base, and actually let's put a 4 on that x, okay, 4th power on that x. All right, our first base is -2, so we're going to keep it. It has a power of 1 on it, so 1 times 3. Now that 2 is a -2, so we have to keep it as a -2, so we have to put negatives in parentheses. X is positive, so it's got an exponent of 4 times 3, so that's going to give us 12. This is going to be -2, still in parentheses, raised to a 3rd power, because that -2 is being affected by your power. So you have to keep that in mind. You can't drop the parentheses until you apply the power. And this is x to the 12th. All right, so -2 raised to the 3rd power means, as we have learned, -2 times -2 times -2, which is +4 times -2, which is -8. So our answer here for -2 raised to the 3rd power is going to be -8 x to the 12th. And that's our final answer. So whenever you have a negative number or a negative exponent, negative base raised to a even number, it's going to come out positive. But when you have a negative base raised to an odd power, it's going to be a negative answer. All right, and that's our product rule. So when you have a base raised to a power, raised to another power, the product rule says that you keep the base and you multiply your exponents.